Hey guys, welcome to Pre-Calc, lesson 9.9, writing trig graph equations. Let's start with a warm-up of graphing, because that's going to help us work backwards to write the equations. Graph two cycles of y equals -3 cosine 2x minus pi. So this has a phase shift, which means we need to factor that out. -3 cosine, let's factor out the 2. If you divide both those terms by 2, you get x minus pi over 2. So now we'll identify amplitude. It's 3. Our frequency, or b term, is 2. So that makes the period 2 pi over 2, which is just pi. Now what else do we have going on here? We've got a phase shift. Right pi over 2. There is no vertical shift, but if you notice here, we have a reflection in the x. So I usually don't write that down, but when I make my thumbnail sketch, I think to myself, okay, what does a negative cosine curve look like? Negative cosine would intersect the y-axis at the minimum, go up and down, so kind of like a bell. So let's sketch that in. And the period is pi, so one cycle will be pi units long. Okay, let's set up our axes. There's no vertical shift, so this should be kind of easy, straightforward. I'll make this my y-axis, put my x right in the middle. Now I need to sketch 2 cycles. I am going to go out 2 cycles for this one. So what I'd probably do is go 2 blocks, 1, 2, 3, 4, make that 1 period, so that's pi, which makes this pi over 2. Now, it's not really necessary if we're going out 2 cycles here that we label every single one of these, but just make sure you're aware that this is a fourth, 2/4, 3/4, 4/4. Okay, so we'll just keep this scale going. 1, 2, 3, 4. So that would be 2 pi, and this would be 3 pi over 2. But we'll be using the fourths, okay, for our critical points, our maxes, our mins, and our midlines. Amplitude is 3. It's not necessary that you label every single one, but maybe just go up 3 blocks and call that 3, and go down 3 blocks and label that -3. I'm totally fine with that. All right, so what are we doing? We're taking these points and we have to shift them right pi over 2. Well, rather than try and think of it as shifting all of these points right pi over 2, let's just take one point, this one, and shift that right pi over 2. Because if you can identify this point, then moving right, I know I'd go to the midline, to the maximum, back to midline, so on and so forth, and there's that pattern over and over again. Okay, so I'll take this point here and shift it right pi over 2. Goes right to there. Great. So now, remember, I'm using these. Those are my critical values. So from here, I go midline, the max, the midline, and there we go. Now we've got our pattern. It's just going to repeat, and then I can back it up to the y-axis. Okay, so midline, then maximum, back to midline, to minimum, midline, maximum. Concave up, concave down, concave up, concave down. And now let's just repeat this process back to the y-axis. So that'd be 0 there and maximum there. Okay, so there's 2 cycles, right? I know there's 2 cycles. Here's one, high point to high point. Here's another one, high point to high point. That's 2 full cycles. And what's cool about this, we talked about it last lesson, is I could rewrite this equation. This ties into today's lesson with all of this information. Amplitude, frequency, but notice this looks like a positive cosine to me. So I could simplify that equation, write this as y equals 3 cosine, what's the frequency? 2x. That's much simpler. It graphs the same thing. This equation and this equation are equivalent. So obviously, if I were to just to write this equation, I'm not going to include all this stuff. I'm not going to include a reflection and a phase shift. You could, but I'm not going to. I'll just make it as simple as possible. Okay, so let's practice that then. Write a trig equation from the following description and sketch 2 cycles. Sine x, it's sine graph. Amplitude is 3, period is pi, vertical shift up 1. All right, so if I'm writing the equation, first thing I like to do if I'm given the period, and I always given the period when it comes to description, is get your b value, your frequency. Sorry, b value. 2 pi over the period. 2 pi over pi is 2. So write this equation. Okay, y equals, amplitude is 3. It's a sine graph. The b value is 2. X. Close your parentheses, vertical shift up 1, plus 1. It's pretty easy. It's actually easier to write the equation than it is to do the graphing from the equation because we can make it as simple as we want. And let's just quickly sketch 2 full cycles of this. Amplitude is 3, shifting up 1, so I'll just move this down a little bit. 2 full cycles. The period is pi, so let's go 1, 2, 3, 4, make that pi. 1, 2, 3, 4, make that 2 pi. Let's just label a little bit more. So there's pi over 2, and there's 3 pi over 2. All right, it's a sine graph. So if I make a quick thumbnail sketch over here, there's sine. What is the period? It's given to us, that's pi. So basically I just need to transfer these points. Pretty straightforward. Okay, so, forgot about my midline. Sorry, almost forgot that. Up 1. And I didn't label my y-axis. I'm slipping up here. So let's do this. 1, 2, 3, 4. -1, -2. All right, my midline, up 1. So that represents this here, starting at the midline. Okay. Then we're going to our maximum. Our amplitude is 3. So from here I have to go up 3, back to your midline, and then from there you go down 3, so that'd be down to -2, back to your midline. I like to do one cycle at a time. This is concave down, this is concave up, and now let's keep that pattern going. Maximum, midline, minimum, midline. Concave down, concave up. Okay, let's keep going here. Write a trig equation from the following description and sketch 2 cycles. Cosine x, amplitude is 1/2, period is 4 pi, phase shift right pi, and a reflection in the horizontal axis. So we got a lot going on here. Okay, so if you're given the period, next thing you do is find the b term, which remember is 2 pi over the period. So I've got 2 pi over 4 pi. Pi's cancel. 2 over 4 is the same as 1/2. There's my b term. Let's start writing the equation. Y equals. Now, reflection the horizontal axis is the same thing as reflection the x if you do that first, so it has to start with a negative. Amplitude is 1/2. That comes next. It says it's a cosine. Next, I list my b term, which is also 1/2, and then in parentheses, I'll put the variable with the phase shift. Phase shift right pi, so that'll be x minus pi. There's no vertical shift, so I stop there. Let's sketch 2 quick cycles. Y-axis, and there's no vertical shift, so I'll put the x right in the middle. Go out 4 blocks, 1, 2, 3, 4, and that's going to be the period, 4 pi. That's 2 pi, so I have to go out 4 more blocks, 1, 2, 3, 4. That's twice the period, so 8 pi there, 6 pi there. Amplitude is 1/2. So to make this easy, I don't want to do this. I don't want to make that a 1 and just sketch this in, like that. So you can set the scale whatever you want. I'm just going to go up 3 blocks and just call that a 1/2. And I'll go down 3 blocks and call that -1/2. Just make sure you label those. So now here's my thumbnail. It's a negative cosine. All right, so if I think negative cosine, looks like this. But we are shifting it right pi. So what I'm going to do, well, first of all, let me talk about the period. What is the length of one cycle? 4 pi. And then with my phase shift, I'm going to take this and move it right pi. So this point here is going to go right pi. It's going to go right to that point. And then from there, what am I doing? I'm going up because I'm following this. So I'm just replicating that over here. Okay. So take that point, move it right pi. It goes right there. There's your minimum. So as you move to the right from the minimum, you go midline, maximum, midline, minimum, and you just keep following that pattern. Now, it's not really a great practice to just start kind of in the middle of your x-axis, so we'll just bring that back all the way here. And then just keep the pattern going for 2 cycles. Midline, maximum, midline. There you go. There's 2 full cycles. Check it out. Valley Hill, Valley Hill. And now if you're asked to write another equation to represent this, here's what I notice. Starts at the midline and goes down. So to me, this looks like a negative sign. So I could create another equation for this graph that is y equals negative, amplitude is 1/2, sine, frequency is still the same, it's going to be 1/2, x. That's a much simpler equation. So if I were just given this picture and not all of this stuff, that's the equation I would write. Okay, write a trig equation from the following description and sketch 2 cycles. Tangent x period equals 4. All right, so if the period equals 4, actually I don't need to write that out, sorry. If the period equals 4, what I want to do is find the b. Remember, for tangent, b, the frequency, is pi divided by the period, because the period of tangent is pi, not 2 pi. So that's going to be pi over 4. So writing the equation is pretty simple. Y equals, there is no amplitude for tangent, tangent pi over 4x. There's no reflection, there's no phase shift. It's a pretty simple equation. All right, and for the sake of brevity here, I am going to skip the graphing of 2 cycles because I want to focus most of my attention on writing equations. All right, example 4, write a trig equation that represents the graph below. And we're going to make these as simple as possible. So the first thing I want to do is identify what my base trig function would be. Now remember, there's actually an infinite number of equations you can write if you include phase shifts. I want to keep it as simple as possible without a phase shift. What I would then do is identify one cycle. This shape right here, to me, looks like cosine. So I've got a cosine. That's my function. What is your amplitude? If the y-axis is not labeled, you assume each block is 1. So my amplitude here is 2. Okay, what's next? The period. The period is the length of one cycle. Again, notice, nothing here is labeled. I don't see any labels. Sometimes they just go way out to the end, just label that, but they didn't even do that here. So if nothing's labeled, I assume that's a 1, that's a 2, that's a 3, that's a 4. So my period equals 4. All right, so I know the amplitude. I know the period is 4. Once you get the period, then you find your b term. Your b term is 2 pi over period for cosine, so that's going to be 2 pi over 4 or pi over 2. So really, that's all I need. If you notice here, I didn't shift it up or down. I'm not talking about any phase shifts. I'm going to make this as easy as possible. So there's my b term, there's my amplitude or my a term, and it's a cosine. So that's pretty easy. Y equals 2 cosine, and then parentheses, your b term, pi over 2x. That's it. Plug that into your calculator, double check in this window, and you get this exact graph right here. All right, example 5, a little bit more challenging. All right, obviously, I see they increased the frequency or decreased the period. They did a vertical shift. First thing I'd like to do here, I didn't do it up here. I got a little bit lazy because to me it was kind of obvious. My midline. So up here, the midline was the x-axis. First thing you should do if there is a vertical shift is identify that midline. All right, so here, I noticed that I went down 1, 2, 3, down 3. That's a vertical shift. The other reason I like to identify that is because it makes it easier to see what my base trig function is going to be. I'm starting at the minimum and I'm going up. That's a negative cosine. All right, so this is negative cosine x. My amplitude is 1. The period is 2 because nothing is labeled. They didn't label anything here. I don't see a pi, I don't see a number. Nothing's labeled. You assume each grid line is 1. So my period is 2. Once you get the period, you find the b value. B equals 2 pi over period. So in this case, the b value is pi. What we're going to incorporate in the equation, it's negative cosine. Amplitude is 1, so you don't have to worry about writing that in. Your b value is pi, and you shifted down 3. All right, so let's write it. Y equals negative 1, which I don't put in, cosine. My b value is pi, so that's pi x. Close your parentheses, down 3, minus 3. So you can see, I think this is a little bit easier than coming up with the graph. Getting the equation from the graph, it's a little bit easier to identify the information. All right, 2 more. Example 6. Write a trig equation that represents the graph below. Again, let's identify that midline. Here's the midline. Look at your scale. I went up 1. So this is up 1. I like to start at the y-axis and highlight 1 cycle. So look at that shape. That shape you should recognize is hill-valley, which is sine. So I'm going to create a sine equation. Amplitude comes next. Well, it's not clearly marked, but I'm assuming that is halfway between. So if that's 1 and that's 1.5, my amplitude equals 1/2. It's a positive sign. My amplitude is 1/2. I went up 1. So check this out. Y equals, amplitude is 1/2. Sine, don't know this yet, up 1 plus 1. So that's a good chunk of the equation. What I'm missing is this, my frequency. Now there's a couple ways that you can get this frequency. If you have a good command of frequency and understand frequency is the number of full cycles between 0 and 2 pi, you can count. There's 0. That's 1 pi, right? This is obviously pulled from a graphing utility, which can't label pi, so I just did 3.14159. So this is really pi. Well, how many cycles are there between 0 and 2 pi if you were to continue this out? Well, you don't even need to go this direction because if you think about it, this distance here is 2 pi. So how many full cycles are there between 0 and 2 pi? Well, let's count them. It's going to overlap my original one a little bit. There's 1 cycle, valley hill. There's 1. Valley hill, there's 2. Valley hill, there's 3. So my frequency is 3. Boom, that's what goes there. B value is your frequency. Now that's a little confusing, okay? And you want to do it the way we've been doing it, where I find the length of 1 cycle. It's a little bit harder because here's 1 cycle. Well, I don't know what this is. I can't estimate that. So regardless of what we do here, if you want to find the length of 1 cycle, what I would probably do to get the period is do this. There are 3 full cycles between 0 and 2 pi. So 1, 2, 3. So I would have to take this 2 pi and divide it by 3. That's the length of 1 cycle. So then to get your b term, you take 2 pi over 3. And you're like, wow, that's a mess. I have to do copy, change, flip, times 3 over 2 pi. 2 pi's cancel, and I get 3. So either way, you end up getting 3 here. But this is a higher level question for sure. And our last one. Write a trig equation that represents the graph below. First thing, get your midline. All right, the low point is -6, high point is 0, so my midline is going to be right here. That's critical for finding, obviously, our vertical shift and also the amplitude. So I went down 3. Next, identify this. Amplitude is 3. One cycle. Goes like this, starts at the minimum, ends at the minimum. So to me, that looks like it's a negative cosine. Great. Last thing, this is kind of easy, is the period. Period equals 4. I'm going to use my amplitude in the equation. I'm going to use this vertical shift in the equation. It's a negative cosine. The only other thing to do is get my b term. That comes from the period. The b term is 2 pi over the period, or pi over 2. So now I can write the equation. Y equals, I said negative cosine, start with a negative. Amplitude is 3, so that goes next. 3 cosine, parentheses, the b term, pi over 2, x, don't forget to put your variable in, and then I had a vertical shift down 3 minus 3. So there's the equation for that trig graph. And that concludes day 9 notes, a little bit shorter than the other ones. Thanks for watching, guys. And as usual, if you have any questions, don't hesitate to reach out. We'll see you in class soon.